Welcome to this video on parallel computing. I'm here to provide you with valuable insights. The voice you're hearing is AI generated, and this video is supported by the Norwegian Research Infrastructure Service. This involves collaboration between the universities of Bergen, Oslo, Tromsø, and NTNU, and working with Sigma 2 to manage the national e-infrastructure. In the previous video, I mentioned the essential move from the login node to the compute nodes for parallel computing. The computing units on login nodes are reserved for running Linux commands and editing program files with editors. It's important to note that every Saga user accesses the login nodes. Heavy computing tasks should be carried out on the dedicated compute nodes, drawing CPU time from your allocated CPU quota. Each user on the Linux cluster has a CPU quota. You should refrain from testing and computing on login nodes to avoid using your CPU quota. Doing so is not fair to other users. This ensures fair usage of Saga and prevents overloading and slowing down the login nodes. To transition from login nodes to compute nodes, you'll need the Linux command salloc that is short for Slurm-allocate. This command offers several options, and you can explore them by typing man salloc in the terminal. Executing this command will display the salloc manual directly in the terminal for your reference. Slurm, simple Linux utility for resource management, is a job scheduler and resource manager used on high-performance computing clusters and supercomputers. Salloc is a Slurm command that allows users to allocate resources for an interactive job in real time. It provides a convenient way to request resources and obtain a shell prompt on a compute node for interactive work. As we examine the salloc command, we find numerous options available. Personally, to streamline the process and avoid memorizing all these options, I've created a Python program. To access it, I simply use the Emacs editor with the Python program named Setup Interactive. I'm using the Emacs editor, although you may use any other editor you prefer. Starting the Emacs editor allows us to take a peek inside the Python program. In our initial video, we demonstrated two keyboard commands for the Emacs editor. The crucial command is Ctrl-X followed by Ctrl-S. This saves any edits you make to the file. Another important command is Ctrl-X followed by Ctrl-C, which exits the Emacs editor, returning you to the terminal. To explore detailed tutorials on using editors for file creation and modification, you can find comprehensive information in the HPC onboarding videos available on this YouTube channel. The onboarding videos provide in-depth explanations and practical examples across various topics. In this particular video, we demonstrate how to use the simple Nano editor. Going back to the Python program, the opening line serves the purpose of eliminating the need to type Python at the command prompt before running the program. In the following line, we bring in the OS module. This module enables the execution of Linux commands within a Python program, offering a broad set of functionalities for interacting with the file system, operating system, and the program's environment. Python programs utilizing the OS module are commonly referred to as Python scripts. The following 4 lines define text variables. Specifically, the variable salloc GPU represents the salloc command with options for accessing an Accel node. Including the n tasks equal to 1 option denotes the choice for a single task, while the partition equal to Accel option states the aim to switch to an Accel node. The GPUs equal to 1 option signals the request for a single GPU. The mem per CPU equal to 500 MB option specifies the need for 500 megabytes of memory for each CPU core. In the select CPU variable, we've structured the select command for transitioning to a normal node. Note that by not explicitly using the partition option, the command automatically assumes partition equal to normal as the partition setting. The CPUs per task equal to 8 option asks for 8 CPU cores. The select GPU variable secures 1 CPU core and 1 GPU on the Accel nodes. Note that we haven't specified the CPUs per task option. When using n tasks equal to 1, it's automatically understood that each task will utilize 1 CPU core. In contrast, the select CPU variable fetches 8 CPU cores on the same normal node. In this context, tasks serve as indicators for the type of parallel computing you're undertaking. When n tasks is equal to 1, it implies you're engaged in shared memory parallel computing. Further details on this will be explained later. Please note that specifying nodes equal to 1 is not necessary when using n tasks equal to 1. Shared memory parallel computing is inherently limited to a single node. Therefore, n tasks equal to 1 automatically implies nodes equal to 1. The select n variable, using the time option, specifies the desired duration for the wall time on the compute node in hours, minutes, seconds. The QoS equal to devel option indicates the preference to wait in the development queue, and the account option designates the CPU quota from which CPU times should be deducted. Notice that NN8999K is my CPU quota, and you would need to fill in your account info. Waiting in a queue is a necessary step to access the compute nodes due to high demand. Opting for the development queue usually results in shorter wait times. It's important to note that the development queue is intended for small jobs on Saga, accommodating up to 128 CPU cores with a maximum wall time of 2 hours. Also, remember that wall time differs from CPU time. Wall time is the actual time having 24 hours during one day. The CPU time is influenced by factors such as the CPUs per task, memory per CPU, and other considerations. For example, in the case of the select CPU variable, the CPU time would be 8 hours, even if the wall time is only 1 hour. The other option variable is designated for additional options, and in this instance, it includes an option to avoid being moved to the compute node C560. The setup variable combines all the elements of the select command, and in this case, we ask to be moved to one Accel node. The following line presents or prints the entire command in your terminal. The last line then executes the complete select command along with all the specified options. To execute the Python script in the command prompt, apply // and then the script's name. The script will first display the complete select command in the terminal, and then proceed to execute it. Upon execution, the Slurm-allocate system assigns your interactive job the job number 11248767. The Slurm-allocate system indicates that the job is in the queue, awaiting resources. After a while, the Slurm-allocate system confirms the allocation of resources. The Slurm-allocate system indicates that it has approved the job allocation. The Slurm-allocate system notes that it's currently awaiting resource configuration. Eventually, the Slurm-allocate system reports readiness on node C78, confirming it as an Accel node. Observe the change in my command prompt. Initially, it indicated I was on the login 3 node on Saga. It now reflects the shift to the Accel node C78. I've successfully transferred my first coordinate from one login node to one compute node on the Linux cluster. However, my second coordinate remains in the MXM directory within the file system. To leave the Accel node after completing testing, I can use the exit command. This will return me to the login nodes, as indicated by my command prompt showing login 3. If testing takes longer than an hour, one must request more time to avoid automatic termination and relocation from the compute node. Keep in mind that you can't request more than 2 hours of wall time if you choose to wait in the development queue. I can use the Linux command cost to check the remaining CPU hours in my quota. If I request 1 hour of wall time, how much CPU time will be deducted from my quota? This topic, exploring CPU billing, will be covered in our next video. I am looking forward to the next video, wishing you all happy computing in the meantime.